Hi everyone, welcome to the next Regents full review. We're going to do June 2023 today, the largely requested. So I'm going to go through the whole thing. I'm going to do it off the top of my head because I never did this, so you'll get to see sort of my thinking through the questions as we go. Alright, here we go. We're starting with our multiple choice. There are 50 multiple choice and then 35 short answers. So let's see how June 2023 goes. Number 1, which two characteristics classify Jupiter as a Jovian planet? So the Jovian planets are large planets, low density. I already know that, so I know the answer is going to be 1. But if you didn't know that off the top of your head, you could go to the reference table and go to page 15, and you could see Jupiter's right here with our large diameter and low density compared to these rocky planets here. So, nice easy question to start off. 1. As observed from Earth, the wavelengths of light from the most distant galaxies are usually what? Okay, so wavelengths of light from distant galaxies. What we need to know here is all the galaxies are moving away from us. So the universe is expanding. That's proof the universe is expanding. Redshifting is proof that the universe is expanding. So that's going to be 3. Rate of Earth's revolution around the sun is approximately what? So we take 365 days to go around the sun. That's a year. That's also on the reference table, page 15. And it's 360 degrees in a circle. So if you divide those out, it's about 1 degree per day. Number 4, different star constellations, so pause right there. The fact that there's constellations in this, I already know that the answer is Earth's revolution. Or it has something to do with the seasons. Those are kind of your two buzzwords for the word constellation. So we want to find something to do with that, maybe. Are observed from Earth at different times during the year because constellations spin on an axis? No. Constellations travel in an orbit around the sun? No. Earth spins on an axis? This is rotation. So just be careful that you know the difference between rotation and revolution. And there it is. Earth travels in an orbit around the sun, which is Earth's revolution. Number 5, Foucault pendulum. There's only one answer for this ever. It's rotation of the Earth. Proved that the pendulum will rotate and change direction. Number 6, the Milky Way can best be described as it's our galaxy, and it's a spiral. So our galaxy. So this is going to be not an elliptical galaxy, a collection of stars. We don't orbit the sun. Well, the Earth does, the galaxy doesn't. Star that it's not a star, it's billions of stars. So one of billions of galaxies in the universe. That looks good. All right, we're cruising. Number 7. How much heat energy is required to change 5 grams of ice to liquid water at 0 degrees? So ice to liquid water, that's melting. Okay, and we need to do 5 grams of it. So we need to go to the reference table for this question. Page 1. We need to find melting right here. 334 joules to do it. But that's only for 1 gram. So it's 334 joules times 5 grams. So for this, you're going to take out your calculator and you're going to type in 334 times 5. And that should give us the answer, which is 1,672. The mass below represents the change in the mass of a potted plant over time. Okay, so it says the bottom of the potted plant is wrapped in plastic, and then it's weighing less because there's 2 weights here and then there's 1 weight there, so it weighed less. So why would the plant weigh less? Weigh less. Why? Well, we got transpiration caused a decrease in mass, condensation caused a decrease. Okay, so first things first, the plant gives off water, right? So that's called transpiration. So 2 and 4 are out, and then it went down in mass. So there you go, 1. The water made the plant weigh less, getting rid of the water. All right, we're on number 9. The air temperature are recorded as a weather balloon rises from Earth's surface. At first, the air temperature constantly decreases for 12 kilometers. Then it remains constant before increasing for another 12 kilometers before the balloon bursts. Which layer did it burst? So 12 plus 12 is 24. So it bursted at 24 kilometers, right? So now we got to go on the reference table to our atmosphere chart here. And we're going to find 24 kilometers. So here's kilometers, 10 kilometers, 20 kilometers. There's 30, so it's in between there. So we're in the stratosphere. 2. Alright, going on. Number 10. The diagram below represents the moon passing through the darker part of the Earth's shadow, called the umbra. And we got locations. So, solar eclipse is here, which means this is lunar. So this is going to be, those two are off. And where can it be seen? It can only be seen at night when the moon is out. So B is going to see it. So it's going to be a lunar eclipse occurring and can be seen from B. 4. It can't be seen from A because they're looking this way. Number 11, here's a crater. The crater most likely formed as a result of what? Okay, it's probably a big meteor came in and crashed here. So something like that. So not a volcanic eruption, subduction, no, evaporation, no, and asteroid, yes. Okay. Number 12, we got 3 jars. Okay, so automatically I know, without even looking at anything, I should know that these 3 have equal porosity. That means that there's the same amount of space or volume in between the particles. This one just has bigger spaces, but there's less of them. And this one has more spaces, but there's fewer of them. So now let's look at the question. To determine the porosity, water is poured into the container. The porosity was found to be, it should be 4, the same. Alright, which one represents a warm front? So you can go through and try to name all these. This one is completely wrong because this shows cool air going above warm air, which never is the case. This one shows warm air above cool air. This looks like could be a warm front, so maybe. This one shows warm air sinking, that never happens. And this one shows cool air going above the warm air. Again, that doesn't happen, so it's going to be 3. Alright, which one shows a typical storm track of a low pressure? Everything goes northeast because of the prevailing westerlies. So it's going to be 1. If you forgot this and you knew the latitude of the United States, you could look right here and know we're in here and see the arrows go up and to the right. Anemometer measures wind speed. Okay, this one's wind direction. This is temp. This is a barometer. This is air pressure. Which means this is your anemometer. 1. The wind is caught in the cups, and the cups spin it, and they get a speed on the wind. Alright, we got a station model. First things first, the temperature is really close to the dew point. There's full cloud coverage, so this is high humidity. So it's probably raining. Based on the weather station, the weather is what? It's definitely cloudy. So fully clouded right there. So partly cloudy is wrong. Calm, most likely not. We got to look at what the symbol is, right? So we'll go on the reference table for that. And look, there are thunderstorms right there. So that was easy, too. Alright, electromagnetic energy travels through space. Alright, automatically right there, there's only one that can travel through space. It's radiation. Done. The intensity of insolation over the next 3 months will do what? Okay, so it's March 21st. So April, May, June. So we're going from March to June, so it's going to get hotter. And that's only going to happen in the northern hemisphere. So it's going to get hotter here. And then at B, it's going to be the opposite. It's going to get colder. So increase for A and decrease for B. 4. 19. Which event is responsible for production of oxygen that first entered the atmosphere? I feel like this question's been on so many of them. It's on the reference table, literally right here. Oxygen produced by cyanobacteria. Yeah, 1. The bacteria. Producing organisms. Since the breakup of Pangaea, it has been inferred that the continent of North America has been generally moving where? Okay, we're going to go to our reference table. Pangea begins to break up right here. So we're here, now we're here, now we're here. So it went north. Technically northwest. 1. The fossil Mucrosporifer is considered to be an index fossil because it existed over what? So I don't even have to look for this because I know index fossils should be a large area over a short time. That's what you got to know for index fossil. To memorize. Compared to the Earth's outer core, the inner core properties are inferred to be what? So we could go to page 10 for this one. Okay, so outer core is here. Inner core is here. So let's see what the question is. More dense in a liquid or more dense in a solid? So it wants to know the inner core. So inner core is going to be solid. The outer core is liquid. So this is going to be solid. And then you could see the densities right there is higher. So it's going to be solid and more dense. Alright, we got a P wave, S wave question. Let's do it. Seismic station 4,000 kilometers from the epicenter of an earthquake records the arrival time of the first S wave at 1:05:40. At what time did the first P wave arrive? Alright, so we're going to go to our reference table here. Go to 4,000. So at 4,000, the P wave comes in at 7 minutes, and the S wave comes in at 12 minutes and 40 seconds. So that's 5 minutes and 40 seconds difference when you subtract those. So now that we know there's 5:40 in between, first the earthquake happens, then the P wave, then the S wave. The S wave comes at 1:05:40. And then the P wave would have to come 5 minutes and 40 seconds before it because the difference is 5:40. So if you just subtract 5:40 from that, you're going to get 1 o'clock. 2. Alright. We got, looks like, some fossils here. So they look kind of like snails. So that means that it's probably going to be ocean. 2. Those things definitely didn't live in the other 3. Alright, we got sedimentary rock layers labeled 1 through 6. The age of the igneous rock is blank. Okay, so what happened here is this one came in, then the igneous rock came in. And the reason I know that is because there's no contact metamorphism lines anywhere over here. So since they're not there, that means that this igneous intrusion did not affect layer 3. Because those aren't there. So it had to come in here, and then layer 3 was dropped on top of that intrusion. So we could, the age of the igneous rock is older than 1 and 2. No. The same age as 3? No. Older than rock layer 3? Yes. Younger than 4, 5, and 6? No. There's your answer. Alright, we got some stream drainage patterns. What affects them? So it's going to be the rock in the stream, generally, and the climate. That's 2 big things. So the structure, too. Alright, we got this. This is a landslide. This was a street, right? See the road, and then this dropped. So it probably dropped because it was like either dry here or moist here. Could be either one of those. Gravity pulled it down, so gravity. Mass movement, definitely. Due to prolonged periods of heavy traffic, no. Yeah, rain, 2. 28. The trench, Mariana Trench, is the deepest oceanic trench. This trench is formed as the Pacific Plate, blank. Okay, so we got to go to page 5. Okay, go here. And Mariana Trench is right here. So Pacific Plate here. Philippine Plate here. The boxes here show that the boxes are the overriding plate. So this is the Pacific Plate subducting underneath the Philippine Plate. Pacific Plate subducting underneath the Philippine Plate, 3. Alright, we got magnetic polarity in the seafloor. So this can, if it's seafloor, that means it happens in igneous rock. Because the seafloor is made of basalt. Okay. So now we have to find, we know it's either going to be 1 or 2. Is there seafloor spreading at the East Pacific Ridge or the Tasman hotspot? So it's probably not the hotspot because mid-ocean ridges are what cause divergent plate boundaries, we could check. So East Pacific Ridge is right here, and yes, there's your divergence. Tasman hotspot, if I can find it, is right here. It's not on a plate boundary, so the ridge. Okay. The relative thickness and density of the oceanic crust is what? So page 10 here, here's your little hint. You could see that the basaltic oceanic crust is more dense, but you have to remember that it's thinner. So the reference table tells you half of that. Iron found in some minerals in basalt can react with oxygen and break down into iron oxide. This changes examples of what? Okay, so react, it's chemical. Since it reacted, it was just chemical weathering. 32. Which feature provides the best evidence that the thick glacial ice sheets once advanced southward over New York State? Okay, so which of these four is proof of a glacier? V-shape is river, caves is chemical weathering, sorted, definitely not glacial ice. Yes, these are the striations. Parallel grooves, those are the scratch marks. 3 minerals that would most likely be found in this rock. So this is gneiss. So we're going to go to our chart here. We're going to find gneiss. And then we're going to look here. Pyroxene, garnet, amphibole, feldspar, quartz, mica. Those are the minerals in it. So pyroxene, good. I already forgot. Calcite, no. That's wrong. Garnet, hornblende, talc. I don't think. Garnet, no. Amphibole, augite, no. Quartz, mica, feldspar. Yep. 4. 34. Which igneous rock's fine grain texture would have a mineral composition of those 3 things? Igneous rock chart. Fine grain. So before we do that, let's just get rid of all the ones that are not fine grain. So pegmatite is very coarse, so that's not going to work. Gabbro is coarse, so that's not going to work. Scoria and andesite. Scoria is glassy, so andesite's literally the only fine grain. I didn't even have to do anything there. Nice. Which mineral is that? Okay. So we're just going to go to our mineral chart. And instead of looking at all of them, I'm just going to try to look for this. Fe3Al. Fe3. There it is. It's garnet. Used for jewelry and abrasives. Done. Okay. This is kind of like the more challenging multiple choice. Which diagram best illustrates the position of Earth, Sun, and Moon and the relative distance between the Earth and the Moon that results in a king tide? Alright, well, we got to read this. Spring tides are extremely high tides. A king tide is an extremely high spring tide that occurs as perigee when the Moon's closest to the Earth. Okay, so we need them to be straight in a row. And it's either going to be 1 or 3. These other ones are going to be neap tides. So, and we need the Moon to be closer to the Earth. Perigee means it's closer, so it's going to be this one. Coastal community can make advanced preparation for a king tide event because why? Moon phases are cyclic and predictable. 1. 38. Which factor is primarily causing global average sea levels to rise over time? Melting of ice. If you're melting ice, the ice turns into water, which makes the sea level go up. 2 major greenhouse gases. You got to know all 3. Carbon dioxide, methane, water vapor. So this shows 2. Alright, we got time zones. Cool. Let's see. What time is it in Buffalo, New York, when it's 5 p.m. in Nebraska? Okay, it's 5 p.m. here. That means east increase 1 hour later is going to be 6 p.m. in Buffalo. It's going to be 1. Altitude of Polaris is equal to the latitude of the place. So what's the latitude of Reno, Nevada? That's what we have to know. Reno, Nevada is right here. It's like under 40 degrees north. So it's close, but a little under it. So it's going to be 1. Which city has the shortest duration of insolation on December 21st? Okay, so December 21st is going to be the winter solstice. So the most north is going to be the lowest duration of insolation on this day, because the southern hemisphere is getting their longest day, so we need the most north city. So let's look here. Mobile, Omaha, Miami, Seattle. It's going to be Seattle. Yep, other three are down there. Seattle. 4 time zones are shown in the map based on longitude. Right? Longitude lines make the time zones, and then obviously day and night is based off the Earth's rate of rotation. 3. Alright. It's abundant, widely available crushed stone. United States produced 1.3 billion tons of crushed stone, which makes it used in highway and buildings, and we got a little breakdown pie chart. Which 2 elements are common in both rocks that make up the 4% section? 4% section, sandstone and quartzite. Okay, so we need to know what's most common in sandstone and quartzite. So quartz, SiO2. That's good to know. We'll go here, look at sandstone. Sandstone is made of sand, and it's mostly quartz. Quartzite is here, mostly quartz. So it's going to be SiO2, silicon oxide. Which rock would most likely be included in a trap rock? Okay, we got to read what that is. Trap rock, usually dark colored mafic igneous rock. Okay. Page 6. Dark colored this side, mafic this side, igneous. So we want one of these probably. I didn't look at the choices yet. Phyllite, obsidian, diabase, rhyolite. Yep. So see how those 3 are on the left? Those are generally lighter. Diabase wins. Which crust rock would most likely weather the fastest? Okay, we want the lowest hardness. Oh, nope. We could do that until they said acid rain. So now we need something with calcite. So limestone's going to weather away the fastest for it, because it's got calcite in it. And if you didn't know that, you could just go here. Limestone, calcite, and then calcite on the back page here. Bubbles with acid. When a driver of a dump truck raises the bed of the dump truck to release the load, quartzite tends to scratch the bottom and sides of the bed easier. Oh, look. So I was just talking about hardness. Quartzite has quartz, which is really, really high hardness. So this is going to be 3. That's going to cause something to scratch. Alright, we got this thingy. Little data table. One reason why carbon-14 was used to determine the age was because carbon-14 has a short half-life. And it's used to mostly sample things that were once alive. So number 3 is going to be the answer there. You kind of just got to remember that. Short half-life is good for things that were alive recently. How much of the original uranium-238 is left in the sample of the zircon crystals? Okay, so this says 4.4 billion years it's been decaying for. So we go here, uranium-238, 4.5 times 10 to the 9th, which is 1 half-life. So if it went through 1 half-life, 50% is going to be left. The iridium-enriched sediment layer was deposited at the end of which geologic time period? Let's see. So it says 65.5 million years ago. So we need to find which period is that ending on. 65.5 is right here. That's at the end of the Cretaceous. Beautiful. All right. There is our multiple choice. Cool. Let's do the short answers. Here we go. Base your answers to 51 through 54 on the satellite image below. Okay. There's meanders, no lakes. Now lakes indicate... Oh. Large band of meanders, now lakes, indicate where Horton River once flowed before it changed its path over time. Okay. Yeah, so it's pretty much saying... right? These used to be meanders here. Okay, fine. Identify the name of the depositional feature formed by sediment deposited where Horton flows into Franklin Bay. Okay, so this is going to be a delta. When the river flows into like a bay or an ocean, it's a delta. So 51, delta. All right, 52. State the relationship between the distance from the shoreline and the average diameter of the rock particles deposited. Okay, the bigger particles are going to be towards the beginning. And then as you go out, it gets smaller and smaller and smaller that are able to be pushed out because the velocity of the water decreases. So it's inverse or indirect. You could write as distance from the river mouth increases, particle size decreases. Dominant process on the outside of a curve, dominant process inside of the curve. Okay, outside of the curve's erosion because it's fast water. Inside is deposition because it's slow and it drops everything off. 54. Explain how abrasion causes the rounding of the rock particles. Okay, so if it's angular rocks, the edges get chipped off as it rolls. So we could say that. We could say, as the rock rolls or drags, the edges get chipped off. Okay. Let's see, 55. East African Rift. Okay. Two plates are the Arabian plate and the African plate to the south. The Nubian plate's moving westward. Okay, so this is a bunch of stuff. So let's see what the questions are, and then we'll come back and get the answers. Okay, what type of plate boundary is at location A? So if you go right here, the Arabian plate is going away. So this is probably going to be divergent, but we can look. Let's go here. Yeah, so look, Arabian plate, it's right here. There's your divergent. Okay. Alright, so 56, it wants us to identify the names of the new plates labeled X and Y that are forming from the African plate. Okay, so X and Y are here. The Nubian, so it's here in the reading. The Nubian plate's moving westward and the Somalian plate's moving eastward. That's the answers. Nubian and Somalian. Okay. 57. One tectonic event other than a volcanic activity that's associated with rifting. So, rifting, that could be like an earthquake happening in that area because it's just rifting is the plates are moving away from each other. So, earthquake's probably going to be your best bet. Alright, 58. Oh, we got isolines. Hope we get to draw them. Yep, 4 and 6 inch isoline. Alright, let's see what we got here. So, kind of tricky because this 4 here is in between the 3.9 and the 8. So we got to go here. We're going to go underneath the 4.5, between the 2 and the 5.3 to get that 4. And then through here, and there's totally 4. And then the other one was 6, I think. So 6 goes in between those two to go there. 6 between here, go between here, 6 there. Great. 2 air mass. The air mass that moved over Lake Michigan producing a snowstorm originated in central Canada. Which air mass symbol is this? Okay, it's going to be CP. CP always comes from Canada. MT comes from the Gulf of Mexico. On the diagram in your booklet, write the letter in each box labeled some position that caused each of the 3 shadows. Okay. A, B, and C. Let me just see what this says. Okay, great. So it's always going to be opposite of the sticks here. If the sun's here, A shadow is going to be here, B shadow is going to be here, and C will be there. be opposite the stick. Okay. Identify the letter of the sun's... Wait, did I pick? Yeah. Draw the parent path from sunrise to sunset from March 21st. Okay. And March 21st, the sun's going to rise directly east and set directly west. So all you would have to do is go like this. That's March 21st. Okay. The letter where it's of the sun's position where it's closest to the solar noon. State one piece of evidence shown on the diagram that supports your answer. So the solar noon is going to be when it's highest. So B. And it's also in the south. So that could be probably another answer. So we could say letter B. You could say the sun is, is highest or closest to the south, because the sun will always be south solar noon. You could also say that it like has a shortest shadow. That might have been a good answer, but let's stick with that. It's good. Alright, life cycle of a star, 63 through 65. Let's just see what the question is first before we read the paragraph. In your answer booklet, complete the table by matching the stage of the star development listed below to its description. Each stage can only be used once. Okay, let's see what we got here. Okay, large gas cloud, and it gives us like a word bank here. Okay, yeah. So this is going to be a nebula. And now we're going to literally have to do this. So 3,000 surface temperature, 10 times luminosity. So we got to go to page 15. And we got 3,000 Kelvin and 10 times luminosity. 3,000, 10. Somewhere like here. That's awkward. It's going to be a giant, probably. I'm just picking the closest. Is that even a choice? Yep. So we'll say those are out. Giant. Okay, 5,501. 5,500's here. 1. So that's here. That's on the main sequence. Great. Okay, 3,000 and 2,000. 3,000 at up to 2,000. Wait, that's a giant. Oh no. What'd I do wrong? Well, that's definitely a giant. So I gotta think about that one again. We're gonna have to find this. Maybe I messed that up somehow. So giant. Okay. So that's out. Main sequence we set out. So we're looking for protostar and white dwarf. Protostar is going to be weird. That might... I don't know. Let's keep going. 13,000.001. 13,000.00. There. That's our white dwarf. So it wants protostar for that one. Was that in the reading? 3,000 Kelvin, 10 times the sun. Let's see what this says. Yep, see? This protostar may reach 3,010. That's what I didn't know. Okay, great. So that answer was in the reading. So we just process of eliminationed it, so we would have got it right still. So all good. Alright, 64. Identify the force responsible for the contraction of gas and dust within the nebula. Easy, gravity. It's right here. They even put in the reading. State the name of the gas that fuels the nuclear process of a star. So that's going to be nuclear fusion, fueled by hydrogen. Did they put that? Yep. See? Those two were both in there, if you didn't know them. So this is going to be gravity. But you could have just known them. But they threw you a bone on those two. Alright, 66. Intertropical convergence zone. Okay. Band of low atmospheric pressure where the winds generally blow towards the equator and come together. Okay. As the sun's direct rays move northward, the ITCZ also moves north, and they move south, then the line moves south. Okay. Explain why the convergence zone shifts northward after the northern hemisphere spring equinox. Because the sun's direct rays are moving north. So, in the spring, right, the sun's direct rays is at the equator, but then after the spring is going to be going to summer, then the summer direct ray is going to be at 23.5 degrees north. So we could say the sun's direct ray is moving towards 23.5 degrees north after spring. That's the reason. I'm sure they took tons of answers for that one, honestly. But anything to do with the rays moving north, it would be probably a great answer. Okay, let's see, 67. Use the map to identify the maximum latitude that the ICZ reached when it shifted farthest north in July. Okay. And then the maximum latitude reached when it's farthest south in January. So here's your July, January. So it's going to be this spot and like this spot. So this looks like 30 degrees north, and this looks like this is 30 south. So maybe that's 23 south. Probably those two. 30 north to 23 south. They gave us the unit. That's nice. Alright, explain why air is rising along... Okay, air always rises because it's warm. That's literally all you have to write. Air rises when it's warm. Alright. Keep going. Next question. The celestial object represents one of the foci. On the diagram, draw an X for the other foci. Okay. So here's the one foci. So this foci is between this distance from C. So the other foci is going to be about that same distance from A. So figure here. They want us to draw like a little X. Somewhere like there. Alright, 70. Describe what would happen to the shape of the orbit if the two foci were closer together. Okay, so if you move these, if you remember from that lab with the thumbtacks on the lab practical, you move these closer together, it becomes more circular. You could also write it becomes less elliptical. More circular. Okay, 71. The letter of the position where the satellite experienced the greatest amount of attraction with gravity, and explain why. Okay, so it's going to be C, because you're going to get the most gravitational attraction from the big object. So as the... What is this? What are they saying? It's a planet? Oh, it's a satellite going around another object. So the satellite moves faster when closer to the object. Alright, 72. It looks like we're going to have to plot a graph. My favorite thing to do, especially on a pen, on a digital pen. It's great. Okay, construct this graph. 35, 45. Oh, great. 1007, 35. What? Oh, it's just one of these. Just wants the wind speed. So August 23rd, it's 35. I'm going to go really fast on this one. So August 24th, so 45, 75. I already messed up. That's on the wrong line. Okay. 100, 115, 165. Okay. 75, 30. Then connect them. My line's going to be very sloppy. It's hard to draw. It's pretty good, honestly. It's better than I thought. Okay, great. We did that. Describe one piece of evidence shown in the data table that supports that Hurricane Katrina made landfall. Okay, when hurricanes make landfall, their wind speed slows down. And their pressure would technically start to go up too, because low pressure means getting stronger, high pressure is weaker, landfall makes it weaker. So we could say the wind speed decreased. We'll just stick with that. You could also say, well, we could say the pressure went up. Both of those are good. A relationship between pressure and wind speed. So you could look here. The higher the pressure, the lower the wind speed. Inverse. Or you could write it out. This is literally the same answer. We could say that I wrote here. As pressure increases, wind speed decreases. All right, 75. All right, relative age. We'll see. So automatically I know that these layers were here and then this got faulted, right? Y and XR looks like an unconformity, which is a buried erosional surface. So we'll see what they have to ask here. Identify the only rock unit that remains in the original position. Okay, it's probably the top one, because all of these other layers got faulted. So A. So far, I have to say, there has not been any hard questions on this, unlike the other ones that I went through. So we'll see, though. I could be wrong. These last 10 questions, I might jinx myself here right now. Indicate the relative ages of A, B, C, D, and fault H by listing the layers from oldest to youngest. Okay, so we're going to do A, B, C, D, and fault H. So C is first, then D, then B, then they were faulted, so then H, and then A was put on top. So that's the answer, because it goes from the bottom to the top. C, D, B, H, A. All right, 77. Identify the letter and the name of the rock unit that has bioclastic texture and mostly composed of carbon. Okay, so we're going to go here. Check this out. Bioclastic texture. Look, right here. Made of carbon. So they want us to get bituminous coal, and it looks like this. So we're just going to look for that. It's D. And they want us to write it. Alright, so 78. Look, I see these automatically, so I know I'm going to be on the geologic timescale, most likely. Layer C is Ordovician age. Identify the name of the index fossil and the name of the nautilite index fossil that we found in this layer. So we're going to go to Ordovician. Here. And we're going to go across, and yours is going to be connected, mine's not. So trilobite is this one, so we need B, and nautiloid is here, so we need D. So B and D index fossil is the answer. B is trilobite, so this is the answer for trilobite. Cryptolithus. And then D is that one, Valcorisaurus. Okay, so we're gonna write those. I can't spell. Crypto, Lithus. And then Valcouroceras. Okay. 79. Okay, we got this map. We got a gradient here, most likely. We know the lines close together means it's steep. We're looking at the stream. Look, the contour lines point the direction the stream's coming from, so this stream's going this way. A is your highest point. Just rattling off some things they can ask here. I don't even know the questions. Contour interval's 10. Okay, let's look. Calculate the gradient between x and y. Okay, so this is going to be 450 minus 400 divided by this gap. So this distance here is going to be measured on this scale here. So to do that, you're going to mark these two spots and figure out about how far away it is. So this is 5. 1, 2, 3, 4. I hope it's 3. I'm just kind of going off my computer screen here. I think it's 3. So 50 divided by 3. You put that on your calculator. And I'm getting about 16.6, but I don't think that's right. Yeah, because it's 2.5. Remeasuring it actually accurately. So if I do 50 divided by 2.5, I'm getting 20, which is actually the answer. So this is a 2.5 mile gap. So it's going to be 20. Really hard to measure on a computer screen, don't recommend. 80. Determine one possible elevation for letter A. Okay, so contour interval is 10, right? So this is 450, so 460, 470. So it's going to be between 470 and the next line up would be 480. So any number between 470 and 480 would be good. So I'll put 475. Oh boy, a profile. So unfortunately, I can't show you how to do this profile on the screen. So that's going to be weird. This is awkward. Your profile should look like right here. So if you don't know how to do a profile, go on my video and watch the profile video and you can do it. Okay? Okay. And we said this. State the general compass direction which the stream flows. So the stream is going to be so we said the contour lines bend upstream, right? So this is going to flow southeast, and your reason for that is contour lines bend upstream. You could also say rivers flow from high elevation to low elevation. That works. Don't say anything weird like it comes out the mouth of the V shape or anything. That's kind of like, I mean, they probably would take it, but I think it sounds kind of weird. All right, 83. On the diagram, draw one arrowhead reference on reference line A, and on B, indicate the direction of airflow on each side of the mountain. Okay, so it's going to go up the windward side. It's going to go up the windward side and down the leeward side. Air rises on this side. That's why you got the clouds, and then it sinks over here. That's why it's dry. Compared to the air temperature and moisture on the west, how is the air pressure and the moisture on the east different? So it's going to be, this is going to be dry, and this is going to be moist. This has clouds, so this is low, which means this is high pressure. So this area is going to be high and dry on the east side. Alright, we got last question here, 85, let's see. State the most probable temperature that will occur on the west side at 1500 meters, and then the east side at 1500 meters. Okay. Oh, I guess the diagram's here. 1500's here. So this spot here is between 15 and 20 on the west, so we'll say 17-ish, 17.5. I can't get my packets in order. So 17.5. And then the east, we're between 20 and 30. So 25. That was an easy one. Alright, guys. Thanks for chilling. That was the whole June 2023. And I have to say, this one was pretty easy. I didn't see any questions on this that were like, wow, this was really hard or anything. It was pretty straightforward. Alright, well, I hope you enjoyed. I will keep making these. Good luck studying. See you later. Bye.